The third method that we can solve for a quadratic is to use the quadratic formula. This is a great option, especially for equations that can't be factored. The quadratic equation is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Pretty complicated, but after you use it, you'll realize that this is super handy. So these a, b's, and c's come from the equation in standard form. The coefficient of a, b, and c is what goes into the quadratic formula. Let's apply this to a couple of equations. So 3x squared plus x minus 2. I have a is 3, b is 1, c is equal to negative 2. Let's substitute this into our equation. Negative 1 plus or minus square root of 1 squared minus 4 times a times negative 2. All of it is divided by 2 times 3. Let's collect our like terms inside the square root and simplify some more. X is equal to negative 1 plus or minus square root of 1 plus 24 all over 6. So we have x is equal to negative 21, 1 over square root of 25 over 6. Now we have to deal with this two separate ways. We have the first x, which is equal to negative 1 plus square root of 25, so plus 5, all divided by 6. And the second option we have is negative 1 minus 5 divided by 6. So our first x is equal to 4 over 6 or 2 over 3. Our second answer is negative 6 over 6, and that simplifies to negative 1. Second example. Please excuse the w squared. It should have said x squared minus 6x plus 13 is equal to 0. Okay, a is equal to 1, b is negative 6, and c is equal to 13. When I have a negative b, I need to be very careful because the first part of the equation requires us to write a negative b. So now I have negative 6 plus or minus square root of negative 6 squared minus 4 times a times c. This is all over 2 times a. Let's continue on. X is equal to 6 plus or minus square root of 36 minus 52. Keep simplifying. X is equal to 6 plus or minus square root of negative 16. Now this is a problem. We've got negative 16 in the square root. So what that tells us is that there's no answers because we can't have a negative square root. Another example here, 4x squared plus 4x plus 1 is equal to 0. A is equal to 4, b is equal to 4, c is equal to 1. Let's substitute this into our equation. Negative 4 plus or minus square root of 4 squared minus 4 times a times c. This is all over 2 times 4. X is equal to negative 4 plus or minus square root of 16 minus 16. This is over 8. Now, our square root gives us a 0. Square root of 0 means that I have nothing, and my answer is now 4 plus or minus 0. We know that plus or minus 0 won't change anything. So in this case, we only have one answer. The one answer is going to be half, 1 over 2. Another incident is you could have something that's not written in standard form. So we need to rearrange this to put it into standard form before we can solve using the quadratic relation. I have 3h squared plus 8h plus 2. This is equal to 0. A is equal to 3, B is equal to 8, and C is equal to 2. Let's use our quadratic formula now, but this time, instead of using the letter x, since the variable is an h, we're going to use h, make this equal to h. H is equal to negative b plus or minus square root of b squared minus 4 times 3 times 2. This is all over 2 times 3. So we have h is equal to negative 8 plus or minus the square root of 64 minus 24, all over 6. Let's continue to simplify. Negative 8 plus or minus square root of 40 over 6. Now, the square root of 40 is going to give us some decimal answer because 40 is not a perfect square. The answer that we have now, we call this an exact answer because we haven't rounded anything. When we throw this into the calculator, we're going to have some sort of rounded answer. So our first h, we're going to have negative 8 plus square root of 40 divided by 6. Negative 0.28. We're going to call this our rounded answer. A second rounded answer will be the second half of the equation. So if I had negative 8 minus square root of 40 divided by 6. Negative 2.39. This is our second rounded answer. Okay, and that is it for our lesson and examples on using the quadratic formula.